Hello everyone. So today we'll be talking about calculating reaction forces in a beam. Okay, so first let's talk about static equilibrium. What is static equilibrium? Static equilibrium is basically that the sum of forces in something that is static or not moving equals to zero. So we can say that the forces in the x direction equal to zero, the sum of forces in the x direction, the sum of forces in the y direction equal to zero, as well as the moments equal to zero. And this is for object that is static slash fixed. Basically, it's not moving. So, now that we know that, let's do a problem. So, we have a beam. That has two supports. But this end be A, this end be B. So this is here. I don't want to put arrows to confuse it with vectors. Okay, so this is a pin joint. All right, so A, pin joint support. And B is a roller support. Okay, and we're going to have force of 20 newtons over here and a force of 30 newtons over here. And this distance will be 1 meter, this will be 2 meters, and this will be 1 meter as well. Okay, so this beam is in equilibrium. We have two ends, A and B. A is supported with the pin joint, B is supported with the roller, and we have two forces, 1 meter from A, 20 newtons, and 3 meters from A, 30 newtons. Now that this is in equilibrium, we know that all of these formulas apply. Now, let's draw a free body diagram. And what is a free body diagram? It's a diagram displaying all forces acting on an object. So, let's draw our beam. Okay, we have A and we have B. So, at A, it's a pin joint, so we know that there's going to be a force in the y direction and the x direction. We'll call this AY, AX. We know there's 20 newtons over here. We know there's 30 newtons over here. And B is a roller, that's why there's only going to be a vertical force, BY. We know this is 1 meter, 2 meter, 1 meter. Now that we know all our forces, let's apply the static equilibrium equations to find the reaction forces in this beam, which would be AX, AY, BY. So, sum of forces in the x equals to 0. Now what are the forces acting in the x direction? We only have AX. Therefore, AX equals to 0, which means that there is no force that this pin joint is exerting in the x direction. Now, let's find BY. In order to find BY, let's do sum of moments about A. And our moment is going to be counterclockwise positive. And our x would be in that direction positive. This is very important in order to get our signs correct. Static equilibrium states that moment about that point equals 0. Therefore, let's see what we have here. So for moment, we have 20 newtons going clockwise, which would be negative because counterclockwise is positive. So we have negative 20 times the perpendicular distance from point A, which is 1 meter. Then we have negative 30, also going clockwise, multiplied by 3 meters. And then we have positive reaction support By going counterclockwise, that's why it's positive, By multiplied by the total perpendicular distance to A. And this distance will be 4 meters. And this all equals to 0 as per the static equilibrium equations. So now let's isolate for By. So By, 4By equals to positive 20 times 1 plus 30 times 3. By will equal 20 plus 30 times 3 over 4. So By equals to, let's get our calculator, 20 plus 30 times 3 over 4. That gives us 27.5 newtons. So we know our AX reaction force, we know our By reaction force. Now, let's solve our AY. So, in order to find AY, we could take the moments about B. However, moment equations, we know that require two things. They require the force as well as a perpendicular distance. An easier way to approach this would be to find the summation of forces in the y direction, as AY is in the y. So we have forces in the y, we'll make this direction positive, equals to 0. Now let's find all the y direction, y component forces. So we have AY going in the positive direction, AY minus 20 going down, minus 30 plus BY equals to 0. So we have AY equals to 20 plus 30 minus BY. We know that BY equals to 27.5, so let's sub that in. Now, let's take out our calculator. So we have 20 plus 30 minus 27.5. 22.5 newtons. There you have it. So the reaction forces acting in this beam are AX equals to 0, AY equals to 22.5 newtons, and BY equals to 27.5 newtons. Remember guys, this was all achieved by applying the forces static equilibrium principle, which states that the summation of forces in all directions for a body that is fixed, that is not in motion, equals to 0. Thank you very much. I hope you guys learned something new.